This is a brief presentation. It's going to be around at most 10 minutes, so we are going to hopefully leave like a little bit late, maybe 5 minutes late. So my name is Nihat, and as they said, I'm an assistant professor at the University of Louisville Ssds department. Just a brief recap. So at the beginning of this year, we got announcement about call for proposals for this test cluster through, I think, Exceed campus clusters mailing list. And we wrote a proposal in February, then we got notified in March that we have been selected to receive this cluster. We didn't receive it yet. I think we are going to get it probably around next month. But we will briefly mention our plan on that. And before that, I would like to thank OpenSFS for this generous donation and promoting research and teaching at our university. So briefly, this is a 32-node cluster. It has 4 MDS nodes, 4 OSS nodes, and 24 compute nodes. So MDS and OSS nodes have mixed of SSDs and HDDs, and 64 gig memory and 8 core CPUs. And compute nodes have 32 gig memory and 4 core CPUs. The cluster will be used by Computer Systems Laboratory, which is directed by me, and I have 2 PhD students there, 2 master's students who will be soon PhD students too, and I have 4 undergrads right now, so it's not a huge lab, so we have a small group. The topics that we are interested in right now is high performance parallel I/O. We have some representative publications which are listed at the end of this presentation. Self-optimizing storage systems, and energy-efficient data retrieval and task placement. So we have 2 main goals: promoting innovation and adoption of open source scalable storage technologies. This is aligned with OpenSFS goals. And also we would like to generate new practitioners and researchers who are expert in storage systems. Okay, so to achieve these 2 high-level goals, we have specific research goals. So the first one is developing new high-performance and energy-aware distributed data placement, data reorganization, and retrieval strategies. So when we install Lustre, we will probably use progressive file layout and the replication that is recently available in Lustre to achieve these goals. We will also consider device heterogeneity, SSD, HDD, and new NVMe SSDs as well. Network heterogeneity, different bandwidth or latency to the client, and server loads in our designs. We are planning to run some real applications. We have some collaboration with bioinformatics and bioengineering groups at our university. One topic that we are working on right now is RNA-seq pipeline, so we are probably going to execute that in the cluster. We are also looking into 3D tumor growth simulations. Additional research goals, we will spend some time on NVMe SSDs to develop new caching, tiering, buffering, and scheduling techniques for them. And while doing that, we are planning to measure systems' overall energy consumption. So to do that, we will purchase some NVMe SSDs first. And then we already have some power meters that we will connect them to the cluster, and we will measure the overall power consumption for every different techniques proposed. In addition to that, we are going to run, of course, some benchmarks, and we would like to measure individual latency contributions of individual components in the I/O stack to the overall latency. So that's another goal that we have. And finally, we will look into host-managed SSDs. These are new SSD designs. There are 2 types, basically. These are also called software-defined or user-programmable. There are 2 designs right now. One is open channel. The other one is multi-stream. So the idea here is from the host providing some hints to the SSD so that SSD can perform better internal data placement. And two main goals are improving internal parallelism and decreasing the garbage collection cost. So we will also spend some time with those. Some teaching and training goals. The cluster will be managed by students, members of the computer systems lab. And I'm teaching some courses, operating systems and distributed systems mainly. And I also teach an independent study course in storage systems. So students taking these courses will be encouraged to use the cluster through class projects. So all the developed software data and I/O traces, if we get any trace, and teaching materials will be available, open source and free. All materials will be shared in our website. And that's it. Any?
Questions or comments, or someone who wants to help fund his research?
There are some of the publications. If you are interested, I'm happy to talk for potential collaboration.
Just a quick comment. You said all your code will be released under GPL v3, but if there's any kernel patches and things, it'll have to be GPL v2.
I mean, we will probably do version 2.
I had a quick question about your storage systems course. I just wonder if you could talk a little bit more about your experience with that. With the storage systems course? Just to see if you could speak.
Yeah, this is an independent study course. It's not like a course that I'm teaching in 14 weeks. So this is I'm assigning specific projects related to my research, and a student is like performing that research. So depending on the project, like one project that might be is looking at the, like as I said, in the I/O stack, including the cluster. So what's the contribution of individual components for the overall latency? So that can be a sample project, for example. And that requires like running some benchmarks, tracing, using, I don't know, certain tracing tools, getting individual trace points and getting latency for those components. Something like that.
Any other questions or comments?